Hello, welcome back. This is Samuel Ambrose Onin. We are still continuing with our files, folder, and directories. In the previous video, we talked about something very interesting. I talked about NTFS file system and FAT32, and I pointed out that there exists other file system as well. And here they are on the screen right before you. We have the zettabyte file systems, which is used for large enterprise application or in a big enterprise environment with high performance systems like in the cloud computing, search engine, and many data centers. You will find this zettabyte file system being used. And we also have extended file system like fourth generation. That four means fourth. So fourth generation extended file system is designed for Linux distribution system. So, even Linux, have their own file system. And Apple also came with their file system called Apple File System, which is a kind of like a version of uh, think of it in terms of NTFS that we talked about previously, and it has all those capabilities as well. And it's designed for Mac operating system, not for Windows. And we have hierarchical file system for Mac as well. This one was designed by Apple. It is a kind of like the FAT32 for Windows, but is used for Mac specifically. And then we talked about the extended version of FAT, which is Extended File Allocation Table. This proves that FAT is still useful, but mainly for small chips inside the motherboard and for flash drives, with larger file support. So that's basically the recap for the file systems, in addition to the NTFS and FAT32 that we have seen previously. So next, we are going to have a look at the file folders and directories. And I have some good news for you. When you look at zero, people think of zero like nothing, but zero is very, very important. You know, Zero is very important. Like now we are going to start looking at the storage and memory measurements. And we cannot do without zero. Why? Because zero defines the beginning and the end of everything that we do. We begin from zero level and we end up at zero level. Power of zero. Everything begins from zero. And when we put that 10 raised to the power of zero, it will give us what? Guess what? 10, any number raised to the power of zero is 1. And any number raised to the power of 1 is that number. So 0 and 1 are the most important numbers that you can get because they provide us with the point to begin doing anything in life. Even if you're going to do a big project, you begin from the first step. You begin by doing a small bit, and bit by bit, you make a bundle of the big project until you finish it. That is the power of the smaller numbers. So zero does not mean nothing. So when you put 0 to the power, 10 to the power of 0, you get 1. And then 1 becomes the power of 10, and that gives us 10. And that 10, so those are the numbers that, are considered as the international number system because we have like tenth, the place value of tenth, of ones, tenth, 100, thousand, and then you keep on going like that. Tenth, 100,000, then 100,000. That is the sequence. You will keep on going until when you get bigger number. For example, here you can see 10 to the power of 0 is 1. That is the place of ones. 10 to the power of 1 is 10. That is the place value of 10. 10 to the power of 2 is 100. That's the place value of 100. 10 to the power of 3 is 1000. Now, think of the rest of the number coming after 1000 as being times 10. Yeah? So 10 going back to the place value of 10. So that place value of 10 means that 1,000 times 10 gives us 10,000, which is another way of saying 10 raised to the power of 4. And then 1,000, 10,000, 100,000. Sorry, I was thinking, I was fast forwarding my thinking. Yeah. Now 10,000, 100,000 times 10. You just keep on adding 10 times, 10 times, 10 times, going like that until when we get our number. So that's how we got the numbers which were used for storage and memory measurements. In the idea was go just ignore the word byte because I'm going to tell you something special about it. So just look at it in terms of kilo for now. Like we have 1 bit terms. They decided to come up with some invention because they wanted to find out how to store, you know, these numbers instead of storing 100 or 1,000 or 10,000 or 1 million or 1 billion. See, 1 billion. They had to do something special. They flipped a bit, you know. Instead of writing 10 raised to the power of 2, they wrote 2 raised to the power of 10 in order to come up with what is known as kilobyte. So kilobyte is the smallest storage space that you can find in a memory, and bit is the smallest unit of information that a computer can process. So think of bit in terms of unit of information that the computer can allow to work with, and then think of kilobyte as the information that um, um, the smallest memory space that a device can have, 1 KB, for example. And then byte, think of byte as the group of bits which is found in between the bits and kilobyte. And that is where the power of 2 came from. So 10 raised to the power of, 2 raised to the power of 10 give us 1 KB. So my friend, thank you for viewing. I hope this video has been informative. I know it's a little bit confusing because of the color, but think of it the way I have just expressed. Think of 0 as being the most powerful number on earth because it gives us the beginning of every number. If you put anything, even 0 raised to the power of 0 is equal to 1. Any number raised to the power of 0 is equal to 1. And then any number raised to the power of 1 is that number. That is why ones and tens, ones and tenths are the most important place values in number, and that gave birth to a hundredth. From a hundredth we go to thousandth. All those with equal sign that you're seeing there, all in red, black, um, uh, with a black background. All those are international numbering system sequence. So I put it in black so that you can see and be able to distinguish them. You know. So thank you for viewing. I hope this video has been informative. I'll see you in the next video.